All right, we're going to continue on today with our discussion of engineering economics. And for starters today, we're going to, first of all, identify and embrace the fact that engineers really like diagrams, okay? Just about everything we do, we have some kind of a diagram that we tend to learn how to draw that is associated or kind of goes along with whatever analytical techniques that we might be thinking about using, okay? And this is no exception. So when we're talking about finances, like we do in engineering economics, it is not uncommon for us to use some kind of a diagram that represents the flows of money, flows of cash that happen in the process of some sort of a project. Okay, and so what I want to show you is what we do for these diagrams. Okay, so first of all, we represent time with a horizontal line. Okay, so we draw a horizontal line and represent time. Okay, we might have a few markers along that horizontal line. So maybe, right at the beginning of something, like right now, we would generally represent that as time 0. And then maybe as time goes on, we would show a few other markers. These can be years, they can be months, they can be days. And we might show those as being like the first period, second period, third period, fourth, and so on. And I'll just, I'll show one with kind of 5 periods going on there. All right. On a timeline like this, okay, we can represent the flows of money either to you or from you with arrows on this diagram. Okay, and it's a little bit like free body diagrams in that if you do these like really strictly, what you would do is you would actually show the length of each arrow being proportional to how much cash flowed. Okay, now having said that, that isn't something that we always do. All right, in a lot of cases you may not know how much cash it is, or you may just put a number next to it that represents how much cash it is, and it's kind of hard to always draw things to scale. So for that reason, I would say that's not a strict thing that we always do. But if you do this like super strictly, then you would actually make the arrow proportional to how much cash flowed at that particular point in time. Okay, and we have a particular direction that we show here. So if you show an arrow, for instance, up, like this, what do you think that means? It's a positive flow. What does that mean? Okay, you gained money, right? It's a cash flow in, all right? So I might put that over here. This is a cash flow in, okay? And so you could have that, and over a period of time, you could have some flows in. So you had a large flow there, you had a little flow here, and maybe another flow in here. And then maybe you have other flows, like maybe in year 1, you have another flow. And each of these might come from a particular, type of transaction that you have to do for your project. And so for that reason, it's not unreasonable for you to make one of these cash flow diagrams such that you might actually have 2 flows in the same period. Okay, so like the example of that would be, let's say that you make a sale, and so you receive money, but then in that same period, you would have to pay maybe someone's salary, right? Or you'd have to buy something, right? So you have both an in and an out that happens in the same period over time. And then, you could have periods where nothing happened, right? That's possible as well, that you might have a period where there were no cash flows. And so you could just leave it blank. And then you have, any range of possibilities for what could happen in these things. So the red ones here I'm showing, these are cash flows out, and the green ones are cash flows in. Okay? So this is the idea of a cash flow diagram, the idea that you have a timeline, and over that timeline you show arrows up being cash flows in and arrows down as being cash flows out. Okay? The next thing I want to point out is that a cash flow diagram is actually a function of from whose perspective. Okay? And let's say that this is from your perspective, like you have a company or a business or some project that you are working on. So I'll say this is your perspective. Okay, and to make it overly simplistic, okay, let's imagine that it's only you and one other entity in the world that are having transactions with one another. So maybe it's you and the bank, right? And that would kind of negate the example I gave earlier, but it's the idea that each one of these, an in, is basically like you go to the bank and pull out some money, or that you get some money, right? Or an out would be you would have to go and deposit money. This would be from the perspective of like your wallet, right? So from your perspective. What about from the bank's perspective? Okay. Everything reverses. Okay. So everything reverses here. Instead of it being like you would show, it would actually show this being something like out, right? In, and out, So anyway, my point with this is that, let's see, we have another one there. My point with this is that everything reverses, okay? So it would look something like this. Okay, and you could put in your time frame as well, where this was 0, 1, 2, 3, 4, and 5. Okay. Now, this gets a little bit confusing sometimes because a lot of times you think of what is stored in the bank as being yours, right? So sometimes the bank itself, you kind of see that as your account. But my point with this is that each of these cash flows, you have to make it clear in your mind where are the resources, where is the finances coming from, and who are they going to, right? So anyway, that's kind of the main point there. This could be you and a friend, right? And whenever you exchange money with one another, that makes it pretty clear whether it's yours or whether it's your friend's. Yes, sir. Yes, so I think your point is if I show something where there's both an in and an out in the same period, right, then you could actually combine those together into a net flow that happened in that period. Is that your basic point? And the answer to that is yes. In terms of how the diagram works, it is equivalent, right? Sometimes, though, people want to show those as two different things because they may have come from two different sources, right, or gone from a source to another source. You might want to keep them separate so that you know the contribution of each and like where it came from. Okay, so that's a good point. All right, so these are the cash flow diagrams that we are talking about. One quick thing to mention here is that when you are using cash flow diagrams, if your storage technique for your resources involves interest, then when you put resources into an account and then you take them out later, those two values are going to be different from one another. Okay? So the idea here is, so this is basically, I'll talk about a future value. And we'll do it in general terms first. Let's say you have this timeline, okay? And what happens here is you are going to put resources into an account, which basically means you have to pay into the account, which means it's coming out of your own resources, right? And then after having stored those resources in the account for a specified number of periods, right, then you get to take some out, okay? And so the idea here is that this was P and this is F, being present and future value. So let's say you are depositing a certain amount of money right now, P. You wait a specified number of periods, and I'll show those on here, out to N periods. How do I know how much future value I get out of that account? Yeah, the interest formula that we covered last time, right? So that would be F is equal to what? P times 1 plus I, assuming that you are just compounding just once per period, right? So 1 plus I to the n. Okay? Well, now let's think of it this way. What if you already knew the amount of f that you wanted at the end of this period? Let's say your question is, I want to have a specified amount of future value, and I want to know how much present value I should put in right now to get that future value. Is there a way you could manipulate this formula? You did it on the homework. Good job. You did the homework. That's good to hear. Okay? How do you do it on the homework? Well, there might be multiple ways you may have approached it, but the easy thing to do is just divide both sides by 1 plus I to the n. If you do that, what you will have is that P is equal to F times 1 plus I to the negative n. Okay, by the rules of exponents. Okay, because basically taking something to a negative power is the same as the reciprocal of taking something to that power that's not negative. Okay, so these are a couple of relationships that we will need when we're thinking about accounts or storage techniques of money that involve interest, and specifically compounded interest. Okay, so we work a problem? Yes, you are excited about this problem. Okay. All right, so right when you get out of college, I'm assuming, we're fast forwarding a few years here, you get out of college, it's not uncommon for companies to actually provide signing bonuses for their employees that they hire. And so let's say that you're going to get this $15,000 signing bonus right when you get out of college. You don't actually have plans right away to have a family, and so you're thinking, what I'll do is live like a miser for the next few years, and I'll try to stock away money. So I'll pretend like I do not have this $15,000, and instead I'm going to deposit that money into an account earning 6% per year, which that's kind of good, but it's actually not ridiculous, right? These days our interest rates have not been all that great over the last few years, but let's just say that that's something you can do, is deposit and earn 6% per year. And your plan is 4 years from now, you're going to pull out that money and it'll be your down payment on a house. Okay? And so the question is, how much will you have as a down payment 4 years from now? That's our question number one. Okay? So how do we do that? First of all, actually, let's draw a cash flow diagram of what we're actually saying there. Okay, we're going to assume here in every case, let's see, that it's compounded quarterly. All right, so that means we need to look at quarters. What does that mean? Okay, there's 4 quarters in a year, right? So there's basically 3-month, chunks of time. That's not an uncommon unit of time to use in certain areas of investing. Okay. So we're going to compound it quarterly, and we're going to do what here? We have our $15,000, which we do what with? Okay, we put it in the bank, which means it goes out of our pocket. Okay, and that's $15,000. Then we wait a specified number of periods. Okay. I'm going to just show these periods as being years. Okay, so this is year 0. We have year 1, okay, 2, 3, and 4. Now what happens in year 4? Yeah, you want to know how much can you get out of there, which is basically a future value, correct? Okay, so that would be back into your pocket, and then from there it'll go into making a down payment on a home. Okay, the question is, what is this value? All right, so how do we do that? The formula, right? And it has this formula, but with one little twist. We're basically finding a future value from the present value okay, which you then multiply by 1 plus the interest rate. But what do we divide by? 4, because there's 4 periods in each year, right? There's 4 compounding periods. And then what else do we do? Okay, we have n times 4, right? So this 4 and this 4, all right, these two 4s right here is because we have quarterly compounding. Okay, so now let's put in our values. What do we know? Okay, we know interest rate. Okay, interest rate is 6%. Okay, number of years is 4. Okay, so we have 4 times 4. And the principal amount was $15,000. Okay, so how much do we expect to have there? Okay, what we'll expect to have is 15,000 times 1 plus fraction of 0.06 over 4 raised to the 4 times 4. Okay, so we'll have $19,034.78. Okay, not bad. So we've done our little cash flow diagram there, and from there we've come up with how much we might have to work with. Okay, now let's say you're not satisfied with that, right? Let's say that you say, that is not as much money as I was hoping to have for my down payment. Maybe that doesn't cover, the entire amount of down payment that you would need to put down so that you can avoid something like private mortgage insurance. Okay, which that's going to be something that, you don't necessarily have to deal with that today, but that's a big question that you will probably have come up whenever you get ready to buy a house. Let's say you need $21,000. Okay, and the question is, how much longer would you have to wait if this is the only amount of money that you're going to put toward it? How much longer should you wait in order to get that figure of $21,000? Okay, well, so how should we do that?
Put the final cost for 20,000, change the 4 year to X, and solve that way.
Okay, so here I think what you're saying is we know the future value needs to be 21,000, right? We know the present value is 15,000. And we have 1 plus, the interest rate doesn't change, right? Nor does how many times we compound it. Okay, so then what? What does change? Yeah, 4 times n. We're trying to solve for n. Okay, and this is where having that calculator is really nice, because that, while you can do this problem, how would you do this problem if you don't have a nice calculator? Okay, you actually have to take the log of both sides, right? And when you take a log, it allows you to take the exponent out as a coefficient in front of the log, right? So then you could take out the value of n there and solve for it. But you don't have to do all that if you've got this really cool calculator. So let's go ahead and do it with that. 21,000 is equal to 15,000 times 1 plus 0.06 over 4, okay, raised to the 4 times, and in this case we're just going to put in a variable of x. Okay. When you're through with that, you can hit the solve button by hitting shift, and then above the calc key you see there solve. And what does that give us? Okay, 5.65 we'll say. Okay. So n is equal to 5.65 years. Okay. I mean, you know, it's actually not that much longer, right? Another year and a little bit more than a year and a half. If you assume that you have to wait until the next compounding period, you might have to wait until, you know, a year and 3/4 from now in order to get that value, and you'll end up with a little bit extra, you know. So, you know, that's how you know how many years you might have to wait. Well, let's say neither of those options is actually your favorite, right? You want it to be 4 years, and you want the $21,000. So the question is, and let's say this is the best interest rate you can find. Okay, and the only way that you have then to influence this, you know, as long as you remain in the realm of the legal, the only way you have to influence it is to deposit more at the beginning. Okay, so what do you do here? Okay, so you could solve for P. You could say P is equal to F times 1 plus 0.06 over 4. That's your interest rate over the number of times per period that you compound. Okay, raised to what? Okay, remember when we use the formula in this way where it's P equal F and then times a factor, we have to actually make this negative up here, right? And this will be 4 times 4. The negative is because we swapped around the direction of that calculation. Okay, so that tells us what? Okay, P is going to be equal to 21,000 times 1 plus 0.06, 6 over 4 raised to the negative 4 times 4. Okay, which means that our value that we have to invest right now to make this happen is $16,548.65. Okay. But the question was actually how much would you have to supplement? Right? You have the $15,000 from your bonus. How much would you have to add to that to make sure you can get to this at the end? So what we'll do is we will take that value and subtract what you got from your bonus. And so the question is, or the answer is, you'd have to supplement at the tune of about $1,500, $1,548.65. Okay? So that we didn't do a whole lot of cash flow diagrams on there because it was basically the same idea each time, but with different givens and what you were supposed to find in each case. Okay, so the cash flow diagram didn't change a whole lot. This isn't exactly the most clear example as to why cash flow diagrams might be needed. It gives us a good warm-up maybe, but we have another reason why these are important to us, and it's for cases where you have a larger number of inflows and or outflows. Okay, so let's do another problem that makes that somewhat clear. Okay, this is kind of a story about my grandfather. Believe it, actually, this didn't really happen, but he is the kind of guy that this could have happened for potentially. Okay, he's a very generous guy, but he was also kind of exacting. All right, so let's say that he's super proud that I got into engineering school, and he really wants to do something to help out. And so he says, I want to cover the cost of your books while you're in school. Okay, so I want you to go and figure out what you think that's going to be. And when you do, come back to me and I'll figure out how much I'm going to give you. Okay? So you go and you talk to a recent graduate, figure out how much they spent on books, and you get that data right down here. This is, and you're assuming that you're going to have these cash flows that happen at the beginning of each of your years of school. Okay? So you have $700 at the beginning of your freshman year, $1,100 at the beginning of your sophomore year, $1,300 in the junior, and $400 in the senior. Okay? Now your grandfather, being the exacting sort that he is, or my grandfather being the exacting sort that he is, he doesn't want to just give me the sum of all that money. Why not? It's not, he trusts me. It's not because I'm going to go blow it, right? He says, well, if I give it all to you right now, you're not going to need to buy those books for your senior year for 3 more years. All right? Why should I give you that whole amount right now? Right? You could invest that money during that period of time, and then I only need to cover a certain amount that's less than that so that you can then take that money and cover those books. Right? So how much does he give you, or how much should you ask from him to really make him even more proud of you because you've really figured this out? So that's the question we're going to answer. We'll start with a cash flow diagram. What does this look like for a cash flow diagram for your pocket? Okay. First of all, we'll start with 0 here. Okay. And then we'll go to year 1. We'll go to year 2. And the last thing actually happens at the beginning of year 3, right? Okay? So what happens in year 1, like at the beginning of year 1, so at point 0 in time? Okay? You're going to have to buy $700 worth of stuff. Okay? So that's an outflow of $700. Okay? But what else happens in that very first year? Well, that's when you're expecting that your grandfather's going to cut you a check or something so that you have money to do this. So that's another cash flow that happens in that very first round. That's what we are trying to find. So I'll just put a question mark next to that right now. Okay? Then what? Okay? We'll have $1,100 at the beginning of your sophomore year. Okay? Beginning of your junior year, $1,300. And then maybe in your senior year, maybe you're going to reuse some of your books that you purchased in the junior year or something like that. Maybe the cost goes down. Maybe you figured out that a lot of your professors don't even use their books that they specify. Not that that ever happens, but, you know. So you only expect $400 there. Okay? And how do we figure out how much each, you know, the sum of all of that? If you take all of those cash flows out that you have from year 0 to 3, how do you figure out how much you need right now to cover all of that? Okay? The answer is it's actually not maybe as complicated as, you know, there's nothing necessarily super slick that you can do about this. You have to look at each of these cash flows and bring it to the present, right? Because each of the cash flows changes its value based on how far from now it is in time, okay? So maybe we'll do, I'll call these like P sub 0, right? Well, that one's easy, right? Because P sub 0 is going to be equal to that $700 cash flow that you have right there times 1 plus what? Okay, we're dealing with, he says, worth 4% annually compounded annually. All right, so we don't have to do anything special in terms of different rate of compounding, different frequency of compounding. So we just put in 4%. Okay, and how far from now is that? That's now, right? So it's nothing from now, right? That means there is no time for it to accrue interest or anything like that. So this value is what it is, and the way that that's represented was with 0 time. Okay? Anything raised to the 0 is 1. So it means that that $700 is just $700 right now. Okay? Well, what about in the next cycle? Okay, I'll just go ahead and put this up here, $700. In the next cycle, we'll say P1. Now what do we have? Okay, $1,100 times 1 plus 0.04. Now what? Okay, to the power of 1. The reason why, actually it's negative 1. Why is it negative 1? Okay, yeah, it is because we're doing here where we're trying to find P from F. And if you remember up here just a few seconds ago, our formula for P from F had your exponent to a negative power, right? And it's because money later down the road is not worth as much as money now. Okay, so we put negative 1 here, and how does this calculate? Well, let's see, 1,100 times 1 plus, oh, I don't need that fraction there, do I? There we go. We have 0.04, and then that gets raised to the negative 1. All right, so that $1,100, your grandfather only has to give you $1,057.69. With the assumptions your grandfather has made, right? That's all he has to give you in order to cover that cash flow that happens a year from now. What about the next year? Okay. Right. And the reason why is that this is happening 2 years. So right, you go here, then here. It's 2 years down the road is where that cash flow will need to happen. Okay. So we'll punch that in, 1,300 times 1 plus 0.04 raised to the negative 2. Okay, so he'll actually only have to cover 12,001.92, or 1,201, excuse me, 1,201.92. Okay, I bet you know how to deal with the last one. $400 times 1 plus 0.04 raised to the minus third. Okay, we'll punch that in here and come up with 355.60. Okay, so you take all of this, you know your grandfather's going to check your work, right? So you take all this to him and show it to him. And how much do you ultimately ask for? Okay, 355.60 plus 1,201.92 plus 1057.69 plus 700. You say, Grandpa, I need 3315.21. All right, which is great, right? Totally great. It's like super great. Okay. Did you say you calculated that? We'll figure that out real quick. So it would have been 700. Let me actually store this real quick. I'll store it into variable A, and then we'll say here we got 700 plus 1100, oops, plus 1300 plus 400. This is what you would have asked for with a simple evaluation of what you think your expenses would be, right? Assuming no interest or anything like that. And so you take that value and you subtract what you just found, 33, 15, 21, okay? Which you can just, if you have that stored like I do, change is 184.79. Yeah. I mean, you're glad you did this, because otherwise, you know, your grandpa, he's proud of you now, right? You're in engineering school. He'll become less proud of you if you don't figure all this out and, you know, volunteer this. So, all right. Now, here's the thing. Your grandpa, remember, he is very exacting. And it turns out he doesn't actually have the money to give you right now. But he still wants to help you. So what's he tell you to do? Yeah, so he says, you know what? Actually, you know, he may even have a really good motive for this. He says, I'm not sure you're going to finish engineering school, right? And my offer is only good if you finish, right? So, you know, I'm going to make it to where you have to take out loans to cover these books, right? I promise you that I will cover all those expenses when you graduate, okay? He's still generous, right? You're still getting the books, right? But you have to actually take a little bit of risk here, and there's a motivation why you have to get done. So, you know, he may even be practicing a little bit of tough love here. Okay, so let's do another cash flow diagram. Okay, what does this one look like? Some of it looks very similar, right? How so? You still have to pay your 700 here. And then you have to pay what? 1,100. Then you have to pay 1,300. And then you'll have 400 here. Now it's where it gets maybe a little bit more tricky. Where does your grandpa's payment come in? Okay, yeah, this is right now. This is 0, this is 1, this is 2, this is 3. He's telling you that he's not going to pay you till you graduate. Okay, and just for the purpose of simplicity, let's assume you go to school year-round. Okay, so we don't have a weird summertime that you have to factor in. So let's say it is actually 4 years later that you are going to graduate, and that's when you get this reimbursement. Okay, so now what? This is what we're trying to find. How much should your grandpa have to reimburse you to cover all of this stuff? Okay, well, let's do it again, kind of similar, but it's a little bit different. Why is that? So now we're talking about future values given a present value, right? We're having to push these values into the future. Okay, so we have this future value given a present value. It's accumulating value over that time. And so we'll do this for period number 0 first. Okay, so for period number 0, we have a $700 cash flow. Okay. We still have, well, actually, we have a different interest scheme now. This is not unusual for there to be an expectation that if you're getting loans, the cost of those is probably going to be higher than if you are trying to take money and go invest it for yourself. Okay, so we now have 11% annually. And not only that, what else? Compounded monthly. Okay, and now, how long from now is it going to be before you get this reimbursement? Okay, 1, 2, 3, 4. And notice I do not use a negative sign here. I don't want to leave it just as 4, though, right? Because there's actually going to be 12 compounding periods in each of those years. Okay? So now how much is this going to be? Okay, 1 plus 0.11 over 12. And this will be taken to the 4 times 12. Which would be 1,084.72. Okay, what about at the beginning of your sophomore year? 1,100 is the flow that you have in that year, plus 0.11 over 12 to the what? Okay, yeah, 3 times 12, because now you only have 3, right? You're starting here, 1, 2, 3 years to get to where he's going to pay you back. Okay, so 1,100 times 1 plus 0.11 over 12, and this is raised to the 3 times 12. So that'll be 1,527.77. Okay. Now your junior year, at the beginning of your junior year, 1,300. 1 plus 0.11 over 12. Okay, raised to the 2 times 12. Okay. It's actually okay if you want to go in here and only change the things that change. Okay. It's like that and like this. All right, so this gives you 1618.28. And then lastly, what do you do for this last one? You just do 1 year times 12 months per year. And what we have there, again, we change this to 1. We go down here and change this to 400. So 446.29. And let's figure out how much all this is going to cost your grandpa. Of course, he can keep his money in an account until then, right, to be able to pay you, but maybe he doesn't have the money. So anyway, how much is going to cost you down the road here a ways? It will be that 446.29 plus 1618.28 plus 1527.77 plus 1084.72. I don't know if any of you sort of in your mind have the sound of a printing calculator going in your ears while I did that right there, but mentally I was kind of thinking that that's the sound effect we should have. All right, 4677.06. Okay, but maybe that's worth it to him, right? Now you're motivated to finish because you weren't before, right? You're motivated to finish because now you might be taking out these loans, and if you don't finish, then he's not willing to pay these back for you. So, Sometimes there's some tough love that's involved. I actually think that the TOPS program could learn a lot from this grandpa. And with that political commentary, we will end today's discussion unless anyone has any questions.